Now let's look at some of the related rates problems that are going to require you to use two formulas. Most of these are going to involve the formula for volume and the formula for surface area. So in example 4, we have a cube. It says the volume of a cube is increasing at a constant rate of 114 cubic inches per second. So to give you an idea, this isn't the best animation, but it's the best one I could find at the moment. But so there's a little extra going on in the picture, but just imagine a cube that is plainly increasing, not so much increasing with all these blocks, but a volume of a cube that's just growing. But this picture is kind of fun to look at, so I'll give you a second to look at. Okay, enough of that. So we have a cube, it's growing. Oh no, accidentally X'd out of the notes. But okay, so we have a cube, it's growing. So draw a picture. Okay, maybe I don't need to draw a picture, but we have a cube, and the cube is getting bigger. Okay, that's a little cube. And the other one's a big cube. All right, so you're going to draw a picture of the situation. Check. Make a list of all the numbers rates given in the problem. Determine what numbers are constant and which ones are not constant. Okay, so the volume of a cube is increasing at a constant rate of 144 cubic inches per second. So that's a rate. So that's a dV dt. The rate of change of volume with respect to time is 114 cubic inches per second. At the instant when the side length is 5 inches. So side is 5, and it says it's at an instant. And we do know that the cube is growing. So the sides of the cube are not always going to be it's not going to be 5 the entire time. It's going to grow. So that changes. What is the rate of change of the surface area? So they want to know the rate of change of surface area. I'm going to use an A to stand for surface area. So they're asking me what's the rate of change of surface area over time. That's what we're going to solve for. Round your answer to 3 decimal places. Okay, so these are the two formula ones because we're going to have to deal with the volume formula for a minute, and we're also going to have to deal with the area formula for a minute. So I would suggest whatever they're asking you to find, that's the formula you need to start with. So surface area of a cube means the area of all the sides added together. A cube has 6 sides, so the formula for the surface area of a cube is 6 times the side length squared, because there's 6 squares. If you are asked for, if you're asked about a shape and you don't remember the formula, go ahead, Google what the formula is. All right, so I found that. Is the area constant? Surface area, no, because the cube is growing, so the area is going to increase. Is the side constant? No, if the cube is growing, the side length is also going to increase. So I don't need to, there's nothing to substitute in. Now it's time to differentiate. All right, well, dA dt equals derivative of 6s squared is 12s ds dt. And then it says substitute in everything I know, and I am asked for dA dt. So dA dt equals 12. They tell me that s is 5. And then they don't give me ds dt. Okay, so I have to find what is ds dt. Okay, so I need ds dt, so that means I need another formula to figure it out. So let's try, and s, by the way, is the side length. So we need to figure that out. All right, well, let's see, what do we know? We know that the volume of a cube is the side times the side times the side. So volume is s cubed. Okay, so I need dSdt. So then I need the rate of change of the side over time. So I'm going to take the derivative of the second formula. dV dt is 3s squared ds dt. Then I'm going to substitute in everything I know into this formula to hopefully figure out ds dt so I can substitute it into the thing I need to find. So let's see, dV dt, wait, I do know dV dt. That is 114. So 114 equals 3, s is 5, squared ds dt. So take that and solve for ds dt, and we get 114 over 75. And again, don't round at this point in the problem, because if you do, it'll throw off the accuracy of your overall answer. So now that I have ds dt, I can substitute it in right here. I can substitute it in right there. 114 over 75. Then I can evaluate and figure out what dA dt is. So dA dt is approximately, when you multiply all of that out, you get about 91.2 square inches every second. So here's our last example. We have another sphere, and this time the sphere is decreasing at a constant rate. So since the sphere is decreasing, that means, I'll just sketch a picture on this one. Got a big sphere, it's getting smaller. So the volume is decreasing, the radius is getting smaller, surface area is getting smaller, everything is getting smaller. Let's see, the volume of a sphere is decreasing at a constant rate of 4,635. So dV dt equals, since it's decreasing, I need to write negative 4,635 cubic inches per second. At the instant when the radius is 10 inches, so r equals 10 at an instant, what is the rate of change of surface area? So I'm going to find, let's see, they let surface, if I'm reading at the bottom, they say surface area. Here's the formula, and they're letting S stand for surface area. So that means what's the rate of change of the surface area? So they're asking me, what is ds dt? Okay, so since they're asking me for ds dt, that's the formula I'm starting with. I'm starting with surface area formula. S equals 4 pi r squared. Surface area changes because our sphere is getting smaller, so don't substitute in anything there yet. Do not substitute in for the radius because the radius is changing as well. So I did this, made a list, wrote a formula. Now it's time to take the derivative. Derivative of S will be ds dt. Derivative 4 pi r squared, 8 pi r dr dt. Let's see, what do we know? ds dt is what we're solving for. 8 pi, do I know r? Yes, I know r to be 10, but I don't know dr dt. I have to find dr dt. Okay, so let's go over here. I'm going to find dr dt. Okay, well, the other formula I have information about is the volume. Volume equals 4/3 pi r cubed. Again, the volume changes, the radius changes, don't substitute in anything. Let's go ahead and take derivative. dV dt equals 4/3. Nope, just kidding. 3 times 4/3 is 4. Pi r squared. 4 pi r squared dr dt. And then, let's see, substitute in everything I know. dv dt, negative 4635 equals 4 times pi. R was 10. So 10 squared dr dt. All right, so when you solve this equation for dr dt, you end up getting okay, so when you solve for dr dt, you get negative 11.5875 divided by pi. Leave that as is, and I can substitute what I have now in for the dr dt. So ds dt so when you substitute in the dr dt into our problem, we get negative 927 inches squared per second.